Should we get started? Cool. Hello, everyone. Thank you so much for coming to my talk. My name is Jarrod. Today, I'm going to speak a little bit about exploration, adventure I had into trying to write a compiler in Node.js. This is me, a little bit about me. I've been writing software for a while, solving problems in different industries. I did some stuff in the real estate industry for a while, building listing systems across North America. I did some network appliance things, doing web performance and security for quite a while. And recently I'm working for a mobile game company, building services and APIs for popular mobile games. So that's me. How did I get here? Why am I talking about all this stuff? So I'm always looking for ways to contribute to the Node community, learn more about Node, everything to do with Node. And I wanted to write some blog posts. And I wanted to write about streams, but I didn't have a project. So I was looking for a project to use to sort of to leverage and write these posts, something that would give interesting use cases and be a little more realistic. So compiler. I thought, could I write a compiler in Node.js? Is it possible? Is it even a good idea? Of course it is. Doesn't really matter what happens. We're going to learn something. So I set off on this plan to try to build this and write some articles about it, and ended up writing this talk as well. So why would we want to do this at all, really? I think compilers are really interesting because they're kind of all around us. They're everywhere. A lot of the tools that we use every day when we work are kind of compilers or compiler-based tools. ESLint, Babel, TypeScript, all of these things use pieces or compilers in some way. A lot of information about compilers is highly academic, which sort of shies people away from trying to get into that field. I thought I could try to build one, challenge myself a little bit, and learn a lot about streams along the way, and try to share that information with other people. I wanted to have a project to work on this that wasn't another to-do app. Nothing against to-do apps, I just don't need another one. So came up with compilers. Let's see. So what is a compiler? We'll go through a bit of a quick overview here of what these things are and how they work before we try to build one. Historically, we would talk about, we'd refer to like interpreters. These take statements from our source code and execute them as they're loaded, statement by statement. And then compilers. These do a similar thing, but output some sort of machine-specific executable code. This landscape has gotten a lot more interesting, I think, recently. For instance, something that we all use every day, the V8 engine that's used by Chrome and Node, has an interpreter, multiple compilers, all of these things working in coordination for the high-performance JavaScript optimization that we all rely on. So that's a much more interesting use case of how these things are put together these days. As well, transpilers have become a lot more popular these days with the rise of TypeScript and Babel and other projects like Emscripten. These take source code in one language or syntax and then output it in a totally different syntax to be compiled somewhere else. Those have become a lot more popular. So what are the pieces of the compiler that we need to think about? There's a bunch of layers. Each of the layers has a very important job to do, and the source code that we write passes through them into the final output format. We first pass through the Lexer, the Parser, a code generator, and then to our output, whatever we decide that to be, depending on what we're building. So let's take a little bit closer look at what each of these does and how it might affect our design and what we implement later. So we start with the Lexer. We have our source file, and as far as our code is concerned, when it's reading the source file, we just have a stream of characters coming in. We have no idea what they are. So the first job is to take these sequence of characters and break them up into tokens that can be used by our language. We end up with things like keywords and operators and strings and all of the stuff that we know. But they have no context. They're just broken up into what each individual piece is and nothing about what they do or how they interact with one another. So we take these then and pass them on to the next layer of our compiler to gain some of this context. The parser. The parser is a little more complex. It takes the tokens from the Lexer and builds what is called an abstract syntax tree, an AST probably from here on out, because it's a tongue twister for me. The parser also does the job of ensuring that the code matches the given grammar and that the syntax is correct. You get a lot of errors thrown here if your code you've written is not correctly formatted or written right. This generated AST represents the structure of your program. The nodes of it can actually be walked by an interpreter and execute your program immediately if you're building something like that. If you've ever done custom ESLint rules or things in Babel, you're actually walking the AST to figure out structure of the code and where problems are. So some people have run into this and didn't really realize that they were working with compilers and syntax trees already. Code generation. So the next stage takes this AST that we've built and transforms it into some sort of executable code, depending what we're building. Sometimes we output an intermediate language that's then executed by a language VM, like we see with Java or .NET. It could be outputting executable machine code for a given target platform, whatever we're trying to develop for. Or in the transpiler use case, a totally different language entirely. So, a bit of a crash course, but what did we learn? There's a lot of compilers, there's some interesting layers, and there's a ton of academic research in this area, like I said, especially in parsers, but I'm not trying to build a commercial C++ compiler. I'm not trying to build the next TypeScript. I just want to build a toy compiler to help learn and play with and have a platform to build on. So we'll use one of my favorite Node core features to break down this problem into small digestible pieces. Streams. Node streams are pretty cool. So let's take a quick look at what streams provide us that will help us and assist in building this project. So the Node documentation has a great description. Streams are an abstract interface for working with streaming data in Node.js. It's fairly simple, but it's important that a lot of people sort of miss that we work with streams all the time. Node gives us streams and we use them, but we can also implement our own streams for all sorts of various purposes. So they are a great interface for working with data. They're also a pretty fundamental part of Node. Almost any application you build, you'll probably be using them in some way. What they do is they allow us to process large amounts of data without storing it all in memory. Things just continue to pass through, and we can process them in a streaming fashion. This is a pattern you'll probably used to from many other systems. Like one of the core philosophies of Unix is the notion of streams. Make small tools, do one thing, do it well, and pass between a bunch of them to perform more complex tasks. So we have 4 fundamental stream types in Node. We have readable. These are connected to some sort of source of data, like reading files or standard in from your terminal. We can read data from those, and it comes in a streaming fashion. We have the opposite. We have writable. They're connected to some sort of output, like your console or writing out to a file. You can stream data into those, and they go to that destination. We have duplex streams. They're a little bit of both, like sockets or HTTP connections. You can send and receive from them. And transform, which I found very interesting for this project, where they're also readable and writable, but the output is based on the input. The common description for these is like compression. Your data comes in, you run some compression algorithm, and then you output it. It's related to the input, but it's different. Streams have evolved a lot. We've had many different versions of streams in Node, and the API has evolved immensely and continues to, with tons of new experimental things in the API. We've got some promise-based APIs in there now for some of the methods. You can use the abort signal stuff that they were talking about the other day to shut down streams. Some of the new language features work very well. We can consume readable streams with async iterators to loop over the chunks coming out of the stream. We can actually create readable streams using async generators to produce data as if it was coming from a stream. Streams, I just find delightful to use. So there's some internal features that also I found very interesting that helped a lot in this project. There's some great buffering and back pressure mechanisms inside. They have a high water mark that allows for memory threshold for the buffering, a type of flow control for the streams. If a readable stream starts giving data to the writable side faster than it can handle it, its internal buffer starts to grow. So it can tell the readable side to pause and wait until he can finish his work, and then it will turn back on and continue streaming. There's some helper methods like the pipeline that we have now that makes for a very clean way to connect streams together. This helps us handle errors in a really nice way and clean everything up once it's all complete. And there's also object mode, which we make use of in this project, allowing us to not just work on buffers or string data, but also pass objects of different types of JavaScript types through the streams. So back to our picture from before, and back to our project. So we had a little bit of a crash course in compilers. We talked about streams a little bit. And using the transform streams as the compiler layers started to make a lot of sense to me. And also using streams would allow adding new layers later, swapping out layers for different functionality, adding optimization layers. It's a great generic interface to work with in a project like this. So, a language. We just have to build a new language, right? This is the fun part. So, I need a grammar for this language. And I wanted to, from what I knew of Lexing and parsing already, I wanted to design it such that it would make those jobs as easy as possible to start with. Simplified grammar is going to make the project a lot easier and let it evolve in it later. So I chose a grammar that could parse with a straightforward state machine, and we'll see a little bit of that later. And I knew I would need a little bit of stack storage, but I didn't want to get too complex with it, just something so that I could at least support conditional statements and loops and things like that. So this is how the grammar worked out. It ended up looking fairly cute because I have to use a lot of keywords to help myself identify things as early as possible in the parser for building the syntax tree. Basically, the idea was to, as early as possible, and hopefully from the very first token in a given statement, we can understand what the rest of it's all going to look like, avoiding ambiguities. Complex logic and places where things could go in multiple directions, I think would complicate it too much for me at this stage while I'm still getting it working end to end. So yeah, we're going to support variables, conditionals, simple expressions, and iteration, and of course we need to debug print because we need to know if things are working. So for my Lexer, I decided to break it into two parts. So I built two transform streams to kind of piece that out to make each stage as simple as possible. The first preprocessor stage, as I called it, has a few very small jobs to do. It just separates the incoming tokens into essentially sequences of the same thing. You end up with numbers and very basic tokens like quoted strings, operators, any sort of sequence of plus and minus and greater than that might be some sort of operator later once the parser knows what you're trying to do with them. And then identifiers, really just consecutive sequences of characters at this point. And we still have white space at this point as well. The second stage takes the tokens from that stage and does a little more complex tokenization and validation. We turn them into tokens that are going to be the ones usable by our parser. So we've separated our language keywords out, the reserved words that make up our language. We've identified numbers and converted them to their numeric values from their string representations. And there's a lot more that will go into this stage as we add more language features. So the separation, I think, will play out very nicely later. A parser. So I had done a little bit of Lexing and parsing before, and I knew that the parsing I would be okay, but building the abstract syntax tree was going to get challenging. So I wanted to get something working that I could learn from and then keep iterating on and making it more and more complex. So there's a number of AST libraries that have APIs available into them. So I figured I could build a parser that could generate an AST in one of these existing libraries and use that for now. There was a few options. Babel has a great API into their AST, which also includes code generation, and that would sort of allow to build a transpiler for now. They would allow this language to build to an AST and then output to JavaScript. LLVM also has an interesting wrapper for Node. That's the LLVM is a suite of compiler tools used by the Clang C and C++ compilers. That would be really interesting because it would compile to their intermediate language, which could compile to almost any other target system at that point. So that's something I'm interested in as well a bit later. So building the AST. what I did was, there's a very interesting tool called AST Explorer that allowed me to essentially reverse engineer how ASTs look when generated by JavaScript to get an idea of what I was trying to output from my parser. Looking at different statements and the way they were constructed, I was able to visualize this and then essentially design the parser around generating exactly that same format and pushing that into the Babel API. So because of the choice of syntax and using this, I was able to build a fairly straightforward top-down parser that could construct a valid AST with Babel. It's an example of what a very simple statement looks like for declaring a variable. So the next part, code generation. Using the Babel APIs, I could generate this AST and then tell Babel to output this as JavaScript. So we have some source code on the left in the grammar that I chose to lex and parse, goes through the Lexer and Parser, and becomes the lovely AST that you see in the middle, and then generates the JavaScript that we know and love on the right. That was very satisfying. So looking at this, you might think, it's probably easier just to do some regex or some replacements and translate one into the other. Probably, but now I have a cool platform that I can extend and add more language features to, add new syntax and type checking and all sorts of things that whatever I want to explore. And maybe eventually swap the AST out for LLVM or one of my own if I want to build an interpreter or something like that. So let's take a quick look at some examples. The language has to make something usable, something you can run. So I had some test cases that I worked with to round out the features of the parser, and I was able to pipe those into the Node runtime and see how they would execute. So here's two that were interesting for me. FizzBuzz, of course, it's classic. Any toy language should be able to complete this task in case anyone wants to use it in an interview. This one really helped flushing out the details of getting conditional statements working. So there's the source, it generates to the AST, passes to Node, and that was the output. I checked the output, and it seems to work, and it was really exciting. So I had one other test case, which was Fibonacci. This was another classic, of course, and this was really the first one I used to get iteration and loops working. It was great having these test cases. Both of them really helped getting the basics of the language because they're really small, they're well known, and they're easy to build. This one did have a bug. I didn't output the 0, so I didn't pass the unit test. So I learned a lot here. What's the future of the toy compiler, and what did I learn by doing this whole experiment? Streams. They're very well suited to this project. A lot of the things I do in my professional career, we use streams. I wanted to do something on my own for this, but streams are amazing, and I really think everyone should use them, think about them when you're implementing things, and this was great for me in this project. One part I really hoped for was a little bit of better instrumentation on what was going on inside the streams when I was running these processes. I had a lot of streams connected together, and there's not a lot of feedback as to what's happening inside them. I looked around, and there was some different ways of looking at it, but I ended up making a local build of Node that adds some diagnostic channel events to the transform stream and some of the read and write streams. That was very, very helpful during this to keep track of how the buffering was working so I could learn a little bit about what was happening with the high watermarks, the internal buffers, some performance metrics, and different counters of tokens. I think there's some PRs open for more diagnostic channel stuff in Node, but I'll see what I can find. Maybe we can get some more of that in. And for the compiler, like I said, I'm not trying to build a commercial compiler. I'm not building the next TypeScript. This is a learning platform for me and for anyone else who's interested in these subjects. I'm going to try to add some more features to it. I want to add floating point numbers. I want to reduce some of the duplication in the parser as I led up to conference, some rushed coding, and once I get some of that in, I'm going to play with getting the LLVM AST implemented. I think that'll be really fun to compile some of this to WebAssembly or some other language. And open source, of course. As soon as I get back, I'll probably open source this and let other people take a look at it if people are interested in this subject or streams or want to see what kind of project of their own they can come up with to help them learn. All right. Thank you so much for coming to my talk. and I hope you got inspired a little bit to build your own pet project and do something fun to learn more about Node. Thank you for coming to my session.